Okay, so here's the warm-up question 1, part A and B. And like I said, I have the chat up, so don't hesitate to interrupt me with the microphone or just chat with me. And oh, somebody put in the chat, can you get rid of your last name? You can edit your name. Please don't change it dramatically. I need to know who you are. Okay, but yeah. Okay, so first one, multiply. Multiply in this context is also called the distributive property. We're going to distribute this to each part of the parentheses. So the word multiplication is used in a variety of ways in mathematics. And in this context, it means distribute. So the first one, we get x times x, which is x squared. And then we get x times negative 5, which is negative 5x. Okay, questions on part A? All right, part B is also distribute or multiply. We go from there to there. Think about the numbers first. Negative 2 times 3 is negative 6. And then x times x is x squared. Okay, you can think of the numbers separate from the variables or the letters. All right, last one here. That's going to be a negative times a negative, which is a positive. 2 times 7 is 14, and it still has the x. This x right here is still in the problem right there. Okay, those are the answers to part A and B. Any questions so far? Okay, factor, new word maybe. I don't know, maybe you've heard it before. It is basically like problem 1 going backwards. We're going to undistribute, okay, or pull out a common factor. You ever heard the term, whoa, can't write and highlight. Have you ever heard the term greatest common factor? Greatest common factor is what happens when you look at both of these parts right here. What do those have in common? What do you think? What's in common in both of those terms? Think for just a second in your head.
X.
Yeah, so what happens then?
X.
The x is written outside, you're all right, yeah, the x is written outside the parentheses, okay? Then we have to think backwards like we did in problem, like going backwards from what we did in problem 1A and B, and think, what would I multiply here to get x squared? So that would be an x, right? Because x times x squared, x times x gives you x squared. And then I would have to figure out what would go there, and it would have to be plus 3 because x times 3, when you go x times 3, we would get 3x. So that's our answer, okay? That's called factoring, or in this context, it's the opposite of the distributive property, undistributing. Okay, next, look at this one. What is in common in all 3 of these parts? The greatest common factor. What do you think for this problem? What goes into 2? What goes into 8? And what goes into 6? All evenly, the same number.
2.
2, they're all even numbers, yeah. Since they're all even numbers, then 2 is the GCF, so you put a 2 outside the parentheses. And then we say 2 times what gives you 2x squared, and it would be x squared. And you go 2 times what gives you negative 8x, it would be negative 4x. And then we would go to the last number out here. We would say 2 times what is negative 6, it would be negative 3. So that's our answer. All right, what questions do you have? Okay, rolling on then. All right, the last one here. This was definitely a challenging problem. We're going to try to write this in vertex form. Currently, it's in factored form. Just like you just saw in the last problems, these are factors. Each one of these pieces is called a factor. So there's 2 factors, right? The first set of parentheses and the second set of parentheses. Vertex form is where you have f of x is equal to a times x minus h squared plus k. This is all the work that we did with the Desmos activity, where you slid the parabolas around, figure out how they moved up or down, all that kind of stuff. All right, so that's our goal. Well, it turns out you can't, it's challenging to go straight from factored form to vertex form. There probably is a way to do it. In fact, I know there is, but it's kind of convoluted and weird. It's actually easier if you go to, so I'm going to star, go from factored to standard first. Okay, now in order to do this, I'll do this one in red. In order to do this, we're going to go way back to what we did before we started playing with algebra tiles. This was like 2 weeks ago. We were dividing this thing up into boxes. And a lot of the different things we've been doing so far all require making these boxes, right? And it's probably going to start to feel a little bit confusing because we're actually using the box in a variety of ways. They're not all the same. For this, you take each of these things and you write them on the outside. And remember, it doesn't matter which order you put them in. If you put the x plus 4 on the top, it's totally fine, okay? And then you figure out the inside part. So it's going from the outside to the inside. And so here you get, is the area of this rectangle would be x by x, which is x squared. The area of this rectangle would be 2 by x, so it's 2x. This rectangle would be 4x, and the last one would be a 2 by 4, which would be 8. Okay, so to write this in standard form, you take your x squared, then we combine these like terms, and we end up with plus 6x. And then we take that last lonely little 8 that doesn't have any friends, and it just gets written down. Okay, so that's standard form. Once we're in standard form, then my next step is to go from standard to vertex. Okay, now we're going to use the area model in a different way. So this is called completing the square. This is what we were doing on Friday of last week, and on Monday and on Tuesday, and it was also on the quiz yesterday. Oh, by the way, the quiz, I plan on making a video answer key for the quiz so you can check out the problems you got wrong, or you can come just talk to me in office hours after class, and I'll go through your quiz with you if you want help with that, okay? But ultimately, you are now responsible for knowing everything on the quiz. It'll be on next week's test, okay? And then this is new stuff, so. All right, so what's different about this purple box is, first of all, it's a square. I tried to draw it more square-like, whereas the red one's a rectangle. And then what's different about this is you have to take the parts. This part goes inside. You start with an inside part. And you remember you take half of this, 6x, and you get 3x. And you get 3x. And so together that makes our 6x. Okay? So notice we're starting with those 3 boxes on the inside, and then we fill out the outside, x plus 3, x plus 3, and that allows us to complete the square and get our 9. So that's different. That's different than the way we did the red thing, right? The red was going from the outside and figure out the inside parts. Completing the square is giving you the inside parts, at least some of them, and you have to figure out that missing square, the 9 in the bottom corner. Okay. Remember what you do next is you take that 9 and you compare it to the 8. In order to get to 8, I need to take 1 away. Okay, that might be hard to see in my lime green there, but I was just trying to call attention to it, okay? So basically then our final answer would be f of x is equal to x plus 3 squared, and then I use the -1, so -1. So that's the answer to the problem. That's in vertex form. In fact, we have it in all 3 forms now. We've got it in vertex form down here. We've got it in standard form right here. And we've got it in factored form for how we started. Those are the only 3 forms we're going to be using for parabolas. Now, each one of these forms contributes to a different part of the graph of the parabola, which is going to be part of what you're tested on. So it's important for you to remember, we've talked about a bunch of the different things already, like the vertex and the y-intercept. We're going to put that together next in notes, like what all these things mean and what they do, and try to see the bigger picture and the big connection today. Before I leave this question, though, does anyone have any questions for me? Okay, so take a second and copy this down in your notes. You're going to want to leave these boxes with a bit of space for you to write in here, okay? We're going to be filling those 3 parts out. We're also going to be describing what goes on here with the arrows. So we'll do that as well. So leave some space in here to write as well. Okay, so take a second and just write that down. I'll pause here. Okay, I'm going forward here. All right, standard form tells you 2 things. The first thing is this A value right here. Right, that A. A tells you how wide or thin. It also tells you up or down. And remember this is like the up or down thing is kind of like if it's negative, it's down. If it's positive, it's up. Okay. Guess what? A is in the other forms as well. It's down here and it's down here too. And it does the same thing in each of those parts. So I'm going to cut and paste that there. Actually make it a little smaller. You already know what it says. So that it fits. Okay. So A, the width or the orientation, right? How it faces upward or downward can be seen in any of the forms. Whether it's positive or negative, and any one of those will tell you if it's up or down. Okay. So, but there's one more thing that standard form shows you. Does anybody remember? It's this thing out here. What does the C value tell you? Nobody remembers? We did it as a warm-up a couple days ago. It's the y-intercept. Which is at 0, C. All right? So it tells you the y-intercept. All right, down below, let's go to vertex form. Vertex form, the H, oops. The H and the K tell you the vertex. All right, hopefully that seems kind of familiar to you. And notice that H would be the opposite sign because there's a negative there. So you have to be a little bit careful with that. Now, there's one more thing. That factored form tells you about the parabola that we're going to learn on Monday, okay? So, but in the time being, we're going to be tackling something else before we get to that. Okay, so all of these things contribute to different components, different parts of the parabola. And parabolas can be used to calculate all sorts of things, primarily in physics. So if you're going to study physics, and most of you are taking physics this year, you're going to be studying quadratic relationships, quadratic patterns in your physics class. The A value also has a connection to gravity on Earth. Like if you throw something and it comes back down, gravity is what's pulling that back down and forming the parabola. So there are a lot of connections to your physical universe here, physical world. And we're going to be solving some problems that relate to real life things too. Okay, so the last thing I want to describe on this is what's going on with the arrows. Okay, so on the arrows, I'm going to use a different color here. If you're going to go from standard form, if we're going to go here, from standard form to vertex form, you complete the square. Okay, completing the square, I'm going to scroll back up and come right back to this in a second. Completing the square is what we did right here. It's this work of figuring out what this number that completes the square is and then how you adjust it to get that number out there. Okay, so you've done that before. That's how you complete the square to go from standard to vertex form. But to go from vertex form back to standard form, we did a couple problems like that in lesson 2.5 on Tuesday. And in order to do that, you actually just use PEMDAS and you multiply it out. okay? Notice that I wrote this in the middle here. It's because to go from vertex form to standard form, you use the order of operations or PEMDAS to multiply it out, but it's the same thing when you go from factored form to standard form. This is the same trick, okay? In fact, we did that here. We used, this is multiplication, and we multiplied this one by this one to turn this into standard form. So we did that today also, okay? So order of operations is always if you're going from down here back up to standard form. But there's one more thing here we haven't done. Going from standard to factored form is called factoring. And that's what we're going to do today right now. Okay? All right, there is a lot of information on this slide. If you didn't have a chance to take notes, you might even take a picture of it or something. This is kind of the key to everything for the unit, really. The only thing is that down here, remember we have this coming soon thing that we haven't addressed yet. Okay? So there's one more thing that we're going to fill out on this. So keep this note handy in your notebook because we're going to come back to it and finish that off. All right, any other questions before we move on? Okay, let's do a problem like this called factoring, where I give you something in standard form and we break it into two sets of parentheses, okay? And you're gonna learn later what it relates to the graph, how it relates to the graph. Okay, so example number one, I'm gonna do this with you. And example 2, 3, and 4, you guys are gonna do in breakout rooms today. Okay, so example number one, take a second to write that down, x squared plus 8x plus 7. Okay, to factor, we can also use the boxes. You're going to get so good at this that you're going to be able to do it in your head probably, but this is a really good organizational technique. Okay, so drawing a box. Now, the thing that's different about this is a different use of this box. We're not going to start on the outside. We are going to start on the inside, kind of like we did with completing the square. But we're going to start with this first and this last number. X squared and 7 goes here. This is new. When we completed the square, we ended with that box. But in factoring, we actually start with these diagonals right here, filled in. You automatically get them. Now this right here is what equals 8x. And we have to decide how we're going to split that into two pieces. Okay? Part of the 8x is going to go here, and part of the 8x is going to go there. All right, so that we got to figure out what goes in those two spots. So in order to do that, what we need to do is we take the 7 and we say something times something equals 7. I'll use a dot instead of an x because we're using a variable x. Something times something equals 7. And we also know that something plus something has to equal 8. That's this 8x. So can you think in your head what two numbers add to make 8, but multiply to make 7? What do you think? You can type in the chat, you can shout it out. Just think for a second.
1 and 7.
1 times 7 is certainly 7. And how about 1 plus 7? Yep, that's 8. So that tells you exactly how to break up this 8x into 1x and 7x. Together, it makes 8x, right? Okay, we've got all the inside parts. All we got to do is figure out the outside and then we'll be done. So it'll be x and this plus a 1 and x and plus 7. And that's it. So our final answer would be x plus 1 times x plus 7. Make sure you write it out with parentheses so that you get full credit, okay? All right, you guys ready to try one on your own? I'm going to hit pause on this recording. Okay, so super quick, we got a box. You don't have to make it pretty. X squared 8. And then you take the 6 and you say what times what makes 8 and what plus, what plus what equals 6. And I know that that is 2 and 4. 2 times 4 is 8 and 2 plus 4 is 6. So we got 2x and a 4x, and you have x plus 2 and x plus 4. Or as someone just pointed out, you look back at the warm-up because this is the problem that I gave you in the warm-up. And we get x plus 2. But in the warm-up, you're going the other way. You were multiplying it. which is kind of a good example because it shows that in the warm-up, you started with the outside parts and then you calculated the inside. And with factoring, you start with the inside to get the outside. It's just completely the opposite type of problem. All right, what question do you have about that one? Okay, I'm gonna give you another one. Please, please, please check in with each other. You guys are gonna do better if you learn to explain your own thinking. You have to do that kind of stuff on the test anyway, if you're understanding it. And then also you're gonna be helping out your fellow classmates if you can help teach, because there's 30 of you and one of me. Okay, so try x squared plus 11x plus 18. It is in the chat, x squared plus 11x plus 18. When your entire breakout room is done, you can just come on back.
I was doing the problem, sorry.
It's all good. You're invited to breakout room 2 though, okay?